All right, we're back on the equilibrium and buffers lab, and we're going to do the buffer portion of the lab, which is part E. So reminding yourself what a buffer is it's something that resists changes in pH. So we are going to create a buffer solution. Then we're going to add strong base to the buffer and see if it changes, how much it changes the pH of the buffer. In order to do our buffer experiment, we have these pH meters which give a digital readout. They're pretty cool. And you basically just stick it into the solution and it gives you a pH. These things do need to be calibrated, but we're not going to show that process today because we are missing the calibration buffers. So, but we will show you how it looks when you read out a pH on one of these pH meters as we do the experiment. So, phosphoric acid and dihydrogen phosphate and phosphate, hydrogen phosphate and phosphate are the three phosphate pieces in the phosphate buffer. Okay, so we're going to start over here on and you're going to record all your pH data in table 1, which is page 8. So that's right here, and this is table 1. Okay, so you're going to Simone is going to read off the pH of pure water, what the pH meter reads. Then she's going to read off the pH of the buffer, of the 0.01 buffer and the 0.1 buffer. Then she's going to add 3 drops and 30 drops and 10 mils of the sodium hydroxide, and we're going to see how the pH changes. Once we do that, then what you guys are going to do here is you're going to graph that data. So the volume of the sodium hydroxide added here will be 0.1 and then 1 and then 10. And so that's what's going across the bottom. And then the pH numbers that she's going to give you here are going to go right here. So you're going to graph all 3 of them. 1 in blue, 1 in green, and 1 in red. So the blue is going to be this line, the pure water. The green is going to be this data, and the red is going to be that data. So you'll have 3 graphs with points. The x-axis being the volume of the sodium hydroxide, and the y-axis being the pH. Okay? So Simone is going to give you the pH of pure water first. Is that good? Are you ready to do that?
Almost.
Okay. She's still working it out.
Saturated potassium chloride first.
So we're following these procedures right here. So we would expect the pH of pure water, hopefully, to be somewhere around 7. And so we'll see how it goes here. What's that?
It's like 6. It's going down.
Can you kind of turn towards me?
Yeah.
Thanks. Okay. 5.3.
It's going down too. Yeah.
It looks like it's
5.2.
5.2. All right.
Yeah. 5.2.
So we'll go 5.2. Do you want to fill it out, or do you want me to?
It might be easier if you filled it out.
All right. Can I use this one?
Yeah.
Okay. So pH of H2O is 5.2. Now we're going to add sodium hydroxide to that, 3 drops, and see what happens to the pH.
Mix it.
And because we added a base, which is a very strong base,
6.1.
we're going up to 6.1. And now we're going to add 30 drops and see what happens.
That's 27.
All right, 30 drops. Holy moly. Ooh, got a glare there. Okay, there we go.
11.1.
11.1.
Now we have the rest of it.
And now we're adding 10 mils. Remember, this is a strong base. We would expect it to go up to the 14 region, especially since it started so low. All right, let's see what happens.
Let me see.
That's weird. 12.3. That looks to be it.
Yep, it's
All right.
stabilized.
We're going to go to 12.3. Which would have been 14 if we would have started at 7, probably.
Mm-hmm.
All right, so are we ready to go on the next one, or should we pause?
It's up to you. I just have to pour. What's the
Let's-
0.1 buffer?
Yeah, let's pause, and then I'll get you guys to the next one.